This is part 6 of section 5.5. I want to find all the solutions between 0 and 2 pi of the equation 2 sine squared x plus cosine x minus 1 is equal to 0. Now, I don't really want to deal with a mixture of sines and cosines unless I really have to. And I know that we have a Pythagorean identity that says sine squared of x plus cosine squared of x is equal to 1. So if I want to, instead of having the sine squared, I can rewrite this as 1 minus cosine squared. Okay, so I'm going to distribute here. And combine some like terms. So I have negative 2 cosine squared of x plus cosine of x plus 1 equals 0. Okay? Now, I want to try to get this thing factored so that I can solve it. And things are always easier to factor and to deal with quadratics in general if your first number is positive. So I'm going to multiply everything here by a negative 1 to get 2 times cosine squared of x minus cosine of x minus 1 is equal to 0. So what I have here is 2 times something squared minus that same thing, minus 1. So I can treat cosine of x as a variable and factor this. And it will factor as 2 cosine of x plus 1 times cosine of x minus 1 equal to 0. So multiply 2 cosine minus 2 plus 1, so minus cosine, and then a negative 1. That's correct. And now we would set each of these equal to 0. So from this one, I would have cosine of x is equal to negative 1/2. And here I have cosine of x is equal to 1. Okay. Inverse cosine of negative 1/2 is 2 pi over 3. So that means I have 2 pi over 3 plus 2n pi. Or I have x equal to 2 pi minus 2 pi over 3 plus 2n pi. And that is 4 pi over 3. Okay. And then inverse cosine of 1 is 0. So x is equal to 0 plus 2 pi n, or technically 2 pi minus 0 plus 2 pi n. But 2 pi minus 0 is 2 pi, and 2 pi and 0 are coterminal. So really, you only get one solution from this. And since all of these are positive numbers and we're adding 2 pi, we're not going to get, anytime we add 2 pi, we're getting too large. So we have 3 solutions here. We have 0, we have 2 pi over 3, and we have 4 pi over 3. Okay? So now I'm going to work cosine of 2x is equal to cosine of x. And I'm going to do this a little bit differently because we've already worked it one way. We worked it directly. Now I'm going to show you, because you do have options when you're coming to work these things. What if I replaced this using a double angle formula? So one of our double angle formulas is cosine of 2x is the same thing as 2 times cosine squared of x minus 1. So let's do that, see what we get. Okay, well, since I have a square here, if I get a 0, I should be able to solve this. So I have 2 cosine squared of x minus cosine of x minus 1 equals 0. And this should look pretty darn familiar. We just solved that exact equation. So we are going to have exactly the same solutions. Which are exactly the same solutions we had when we worked at using the other method. So all of these equations were equivalent. They all have exactly the same solutions. Okay, now there's one last method we have for solving trig equations. And sometimes we may need to square both sides of an equation to be able to use an identity to make the rest of it look nicer. And what we learned back in algebra, when we squared both sides of an equation when we have a radical in there, it made things nice, but we had the possibility of getting false solutions, and those are called extraneous solutions. And we had to do a complete check of every single possible solution because you just don't know which ones are going to be false. So we're going to have that same basic idea. We're going to end up squaring both sides and solving an equation, and we're going to have a list of potential solutions. But we're going to have to check each and every one to make sure that they work. So let's do this one problem. I want to find all solutions between 0 and 2 pi of square root 3 tangent theta plus 1 is equal to the square root of 3 secant theta. We're told to square both sides, so square both sides. This is a binomial squared, so you need to make sure that you use either the formula to do that, or you write this down twice and use FOIL/distribution. To square a binomial, you square your first term. The square root of 3 squared is 3. Tangent squared theta. First term squared. Sign from the middle, plus. Multiply these together and then double it, and you get 2 square root 3 tangent of theta plus square your last term, and that's a 1. Okay, now square this. This is not a binomial because there's no addition or subtraction in here, so you simply square each part, and you get 3 secant squared of theta. Okay. Now, one of our Pythagorean identities was 1 plus tangent squared of theta is equal to secant squared of theta. So I'm going to make this substitution right here so that I will have all tangents in my problem. So I have 3 times 1 plus tangent squared of theta. Now distribute. Three plus 3 tangent squared. Okay. Now I have 3 tangent squared on both sides, which is going to cancel out when I start moving things around, which is really nice because it means that I'm going to be able to get tangents by itself and not have to worry about factoring or doing anything else. So to get tangent by itself, I'm going to subtract 1 from both sides. 2 square root 3 tangent of theta is equal to 2. And then if I divide both sides by 2 square root 3, tangent of theta is 1 over square root of 3, which is square root 3 over 3. So inverse tangent of square root 3 over 3 is pi over 6. Plus is pi over 6. So theta would equal pi over 6 plus n pi. All right, so let's figure out all of these possibilities. If n is 0, I have pi over 6. If n is 1 and I add pi to that, then I get 7 pi over 6. And then if I add pi again, then it's too big. So I have two potential solutions, and I need to check them both. So let's check. If our theta is equal to pi over 6, then we have, well, tangent, I'll go ahead and undo this. Tangent of pi over 6 is square root 3 over 3. And I need to figure out secant of that, which means finding cosine of that. But secant of pi over 6 is the reciprocal of cosine of pi over 6. And this is 2 square root 3 over 3. So plugging that in up here, I have square root of 3 times square root 3 over 3 plus 1. And I'm hoping that is equal to the square root of 3 times 2 square root 3 over 3. 3 over 3 is 1, so I have 1 plus 1 here. And this ends up being 6 over 3, and I have 2 equal to 2. So that one works. Now let's check theta equal to 7 pi over 6. Tangent of 7 pi over 6 is square root 3 over 3. And secant of 7 pi over 6 is negative 2 square root 3 over 3. And if I go and plug that in, I have square root 3 times square root 3 over 3 plus 1 is equal to the square root of 3 times negative 2 square root 3 over 3. And here we end up with 1 plus 1 is equal to negative 6 over 3. And we get 2 is equal to negative 2, which is not true. It's false. So this was an extraneous solution. Our only answer here is pi over 6.